Right. So here, I want to show the 3D. All right. So that's the 3D that we had last time. And if you guys remember, we created a grid system at -3 so that we can move the hinges from the first floor to the basement or whatever, to the ground floor. All right. But the thing is, you can consider this model is ready to be analyzed. Like I can hit run and get results. But the thing is, I want you to look at the location of the walls that we have here. The wall that we have here, let's zoom in and see what we have. The wall mesh is very big. Okay. Look, this is the wall that we have. What we did last time, we had a frame element. We extruded this frame element into a shell element, and then we had this wall. This wall actually is not a wall. Like if you run the analysis like this, the software is going to deal with it as a deep beam. It's hinged here and hinged at 3 meters, and it's deep, and it's going to be like a beam. Okay, but this is not how it is. This wall is not supported at the start, at the end. It has a foundation all the way over the length of the beam, either a strip foundation, either a bile cap or something that goes from here to here. And if you guys remember, this is a very, very big shell. And if it's a big shell, the analysis is not going to be accurate. It's like 3 meters by 3 meters. So we need to divide it in a much smaller mesh. So this is note number 2. Number 3, look at the shell system of the slab. You will find it's divided into small meshes. Each mesh is less than 0.5 meter by 0.5 meter. And then it gets connected. I'm not sure. And I always forget to bring like a piece, like a paper or something. Can you give me, you guys have any like A4? Okay, thanks. So yeah, so here, that's the wall, this way. And there's a slab is connected to this wall here, but let's say this is the whole mesh of the wall, and there's a mesh area from the slab coming loading on this wall like this. This wall is not going to feel anything from the slab, only at this joint and this joint. Any loads that comes from the joints in between is not going to feel it. Okay, and this is not when it's going to deform. The deformation is going to be separated from the wall. Like you will feel that the slab is actually not connected to the wall, only here and only here. The only way to solve this, you have to divide this wall in a way that can connect with these meshes. Okay, that's a fatal mistake in finite element if you read it like this. Okay, so that's note number 1 that you have to take care of while doing finite element analysis. All the joints have to be connected. If a wall is not if a column or a wall is not connected to a joint on the slab, this column is not going to feel any load from the slab. So if you have a column, this column needs to be connected to a joint. You have a wall, all the joints on the wall need to be connected with the joints on the slab. So for example, say that you divided this wall into mesh size 0.5 by 0.5, but somehow, by the way, if you guys remember, when I divided it into 0.5, I didn't make it exactly 0.5 by 0.5. I told the software the maximum size is 0.5 to 0.5. So I'm not sure what is exactly the size of the mesh. Maybe 0.4, maybe 0.45. So if I divided this with a maximum size 0.5 by 0.5, this doesn't mean that it's going to connect with this one. What I want to make sure is I need to divide this in a way that can connect with the same size of the slab. Okay, that's a very, very important modeling aspect when it comes to finite element. You have to take care of this. So number 1, joints have to be connected. Mesh need to be small as 0.5 by 0.5, and definitely we need all the base condition here to be have the same condition, not at the start and not at the end. So let's see how we can do this. So to do this, what I need to do, I need to select all the walls that I created. Like to do this, you can select them one by one, or you can go to select properties, and then area section, and then we have a wall section 30 centimeter, and I'm gonna select. So this is gonna select all the walls here, and we have actually 12 walls. You can see how many selected walls
in the below left corner here, 12 areas. Okay, right now I selected the walls. Second, I need to select the joints that I'm gonna divide this walls at. I know that this wall is gonna be divided. This one is gonna be divided at these joints. Okay, I need to select. Oh, I have problems with the zoom now. So let's. All right. So whenever you make like this, like I try to zoom, maybe you can close the view and recreate the view again. Like you can actually close this view and then here you can add a new window and then I can make this XY. And as I see all the walls are selected. So let me make the zoom here on this wall. And then you select the joints on this wall. So right now I selected all the joints that I need to cut this wall at. So you have to do this for all the walls in the drawing. And once you select all of them, I would recommend you to put them in a group. So before I come to this lecture, I selected all of them and I assigned them to a group. So if I said select, and assignment, groups, and I will find a group is called wall joints. So if I select this one, it's gonna select all the joints of the walls. Like you can see, all of them are selected. To do this, after you select all of them, you go to assign. I mean, like to create the group from verse. Once you select them, let's say that we went one by one and we selected them and we have this selection right now active. I go to assign and then we will have assign to group and then you define groups and then add new group and name this group, like name it points, group 1, group 2, whatever you want. And then once you do, you hit OK, OK, and now you have group 1 is selected. So if I escape this selection somehow and I want to select it again, I go to select groups, and then I will find group 1 and then I will hit select. It should interesting. It didn't assign them to group 1, but they are still in this group. Okay, so let's try it again. Assign to group. Okay. Add to group 1. Apply. Select groups. Let's see if they are in group 1. Okay, they are in group 1. Okay, so we have them selected. So the thing is, the selection of the wall is gone right now, but it's easy to select it again. So I'll go to select properties, and then I will go to area section, wall, select. So right now I selected the walls. And what I want to do, I want to edit, divide the walls. Okay, I will go here, divide area based on points, and then select selected points object on the area. So I want to divide this area with the selected points. Okay, let's see what's going to happen. Okay. All right. So, all right, let's zoom in and see what happened. I'm going to zoom to the 3D. Look what happened here. So we have the wall is 3 meters, right? So when we divide it with the joint, it just make a division in this direction based on the joints here. So right now, I'm sure that all the joints from the slab is connected with the wall, but the aspect ratio of the element is not as acceptable.
we need to have like an acceptable aspect ratio, like a ratio between this dimension and this dimension. Okay, so it's divided in this direction, but what we need to do, we need to divide it in the other direction. So I know for sure that here it's almost like 0.5 by 0.5 meter in this direction. So I want to select this walls again and divided it into the other direction. So what I'm gonna do, I'm gonna edit, I'm gonna select first the properties area, and then I'm gonna select the walls again. They are all selected, and then I'm gonna edit area, divide area, and this time I'm gonna divide the area maybe into a number of objects or in a maximum distance. So I know that the floor height when I create it, it's a 3 meters. So if I want to divide it into 0.5 meter mesh, I can divide it into 6 pieces. So I can say here, divide this element into 6 pieces in the direction 1, 2, and keep the other direction not divided. So 1, 2 is this direction, 1, 3 is the other direction. So I can make this 6 and the other direction 1. Why I'm not dividing in the other direction? Because it's already divided. I don't want to divide this element into 6 more elements. It's going to be like very, very small. So I'm going to make this 6. So because I want to divide it into the up direction, not into this direction. So I'm going to hit OK. And let's see what is going to happen. All right. Actually, it divided it into the other. Oh, okay. So it should be the other direction is the 1, 3. Select. Okay. If I want to make sure that the axis direction is right, so I can go here and I can go to area sections and you will find local axes. I will hit apply and I check the local axes. So axis number 1 is the blue. That's number 1. Number 2 is the red. Number 3 is the green. So what we need to divide in the green direction. Sometimes the axes are rotated. So if I want to make sure I can show the local axes from here, I'm gonna hide them because it's gonna distract me. So I'm gonna hide them, and then if it didn't work, actually the easiest way is like if you don't know what axis direction is, you can divide them. If it didn't work, I mean, like if it shows that the axis direction is not the one that you are expected, you make Control Z and get back and divide it the other way. So I'm gonna make this 6, and then I'm gonna hit okay. So right now it's divided correctly this time. So right now I'm done with the wall. All right, so I have here all the wall sections are divided except one wall that hasn't been divided yet. The model is a little bit heavy because we have lots of meshes here. Okay, so I want you to look at this wall in the middle. This wall is divided just in one direction, not in the 2 direction. Why? Because there wasn't any joints from the slab connected to this wall. Look, the one here in the middle. So what I'm gonna do, maybe I can select this wall and divided it into the other direction, this one. So what I'm gonna do, I'm gonna select somehow this view is not making me selecting anything. So let me close this view and
All right. So interesting. It sounds like it's selecting, but it doesn't show in the view. Okay, so let me make this. All right, so now they are all selected 6 areas. So right now I can edit area, divide area, and then I'm gonna divide them in the other direction. 6 in this direction, and I'm gonna keep the other direction is not divided. So now I have all the walls are divided, connected to the slab, but I need to add hinges at the other created joints. So I need to go down to level number -3, and I'm gonna select all the new joints that are here. You will find out that joints are created at the base. Here, I'm gonna assign joint, restrain, and then I'm gonna add hinges, and then I'm gonna say, okay. So right now we have our 3D model ready to run, but this is only one floor. So we can run and see how does the results look like. But this one is a fully 2D or 3D model of a story number 1. So we are done with this, and then I can run this model and run all the load patterns or cases. Did you guys download it SAP 2000, start working? The trial one? Okay. Yeah, some screenshots. Yeah. Hmm. What? Well, they pose. Well, that's a good question. Sometimes, like if you don't have what they call it, sliding scaffolding, but if you are like the reinforcement, the first thing that you have your shear walls and the reinforcement is coming out, and then you put the concrete and make the concrete of the slab and the shear wall together and the reinforcement of the slab going on top of so they are all as a one element. I mean, like they are not one element, but they are connected together. But sometimes they make the shear walls first. And what they do is at the connection of the slab, like every time, not every time, sometimes or most of the modern construction right now, what they do is they make the shear walls verse, because there's a way that you can construct the shear walls fast. And then at the location of the connection with the slab, they put the reinforcement, but then they bend it and then they cover it somehow, and they leave this area ready to be connected with the slab. So once you come to the floor that you have the slab in, they start to like there's a way to do it. You know? Thank you. Yeah, sure. Okay, so here right now I run the model. So if you want to show analysis results for this one story, you can come here and you can get joints reaction. You can get frame, like for example, I can get the bending moments M33 due to combination number 1, and then I'm gonna hit OK. And the thing is, I can't see the bending moment. I need to have 3D so that I can see it. All right, let's see what we got here. Yeah. So here, if you make a zoom in here, you will find the bending moment on this beam. And here's it's positive, and then when it comes to the wall, it's negative, and then it goes down. Okay, you tell me. This moment is not continuous. If you have a hinge here, like if I have a full 2D model, okay? And if I have a full 2D model, this wall doesn't exist, and there's a hinge here, right?
if you have a hinge here, this moment is gonna be it's gonna be continuous. Like, can you see here's the moment? Here's bigger than there. Right now, here's a much bigger moment, and then the moment is getting reduced once you pass the wall. Why? Because this wall takes some moment from it. Okay, so but if you calculate the moment at the street, like if you sum the moment at the wall here with the moment here, it's gonna be the same or equal to the value of the moment here. Okay, so that's why 2D model is more conservative. Why? Because you don't transfer any moment from the slab to the beams or to the shear wall. I mean, like to any moment from the slab or the beams to the columns, because the columns, there is no inertia. There is no a frame section that can absorb moment from the beam. It's just a hinge. Okay, so that's why it's more conservative. Okay, all right, the same thing here. The column at the moment at the column is a little bit is absorbed from here. Okay, but the moment on this column is in the other way. This moment, like to know, like if you want to convert this value, you're gonna tell me, oh, you want to tell me that this difference in moment is the same as this one? No. If you want to do this, you need to show the moment in the other direction, because that's not the moment that is like absorbed from here. So if you want to see it, you need to go here and frames and show the moments M22. The beams definitely is going to be 0, but the columns is going to have a little bit of M22. It's going to be, yeah, just, you see, like negative 1.2, just a little bit, not absorbing the whole moment. You can see it's 0, but once you put your cruder here, it's going to show you that there's some moment. Like, let me click here. And it's supposed to show us, yeah, here's the bending moment. It's 0 down, and then the maximum is negative 1.246. Okay. So that's the moment that is absorbed from the beam, because the column is going to bend. It's going to have a bending moment this way and bending moment in the other way. And the one with the slab is the one this way. The one that comes from it is the other way. Okay. So anyway, so right now, if we want to show, for example, let's show the XY and then show the bending moment on the slab. Somehow. F4 undeformed shape. Okay, I need to go up a little bit, and then I'm gonna show the bending moment, not on the frames, on the shells. And I want to see, for example, M11. All right, so that's the bending moment on the slab. I want you, when you go home, you do this model the way that we did it last time, without the 3D and with the 2D, and convert the maximum bending moment. And this is slab here, and the slab that we did it 2D. What is going to be bigger, this one or the one that is 2D? 2D, why? Because there wasn't any 3D elements to absorb moment from the slab. So right now we have more elements. We have rigid elements, shear walls, columns, absorbing moments from the slab, and then make the bending moment at the slab a little bit less, not much. Like maybe you will find the bending moment is 5 ton-meter from the 2D. This one is going to be maybe 4.5. Okay. All right. So that's why we do 2D, because it's more conservative, and in the same way, it's more simple. Okay, so once we are done and we did all the gravity analysis, when we say we want to design beams and slab, that's called the gravity load analysis. To do a 3D model, that's for lateral load analysis. We need to find out if this building is exposed to earthquakes or severe winds. How can we design for this? We need to make a 3D model so that we can model the masses and the stiffnesses of the laterally resisting elements. Like when I say lateral load resisting elements, is the columns and the shear wall. That is the only elements that can resist lateral loads, like seismic and wind loads. The beams, the frame, the beams and the slabs doesn't contribute much. The beams can, because it makes framing system, but still shear walls is the biggest element. Like let's say, for example, you have like Burj Khalifa in Dubai, okay? So this is actually a shear wall everywhere. Like there's no, like all the walls there are shear walls, right? You have beams maybe somewhere around the building. But the thing is, the beams are not gonna absorb lateral loads until the shear walls is broken or something, because there's a very stiff elements
the earthquake need to get over with so that the other moments can be transferred. Like, let's say, for example, we're gonna discuss lateral loads in details, like maybe in 2 lectures or something. Okay, like, let's say that we have a shear wall here, okay? And then you have a frame system here, columns, and here's my stories, 1, 2, 3, 4, 5, okay? And that's a shear wall. That's a very, very stiff element. And then an earthquake hit and shake the ground, or a wind load is distributed on this building this way, right? This columns is not gonna absorb an earthquake load because to resist the load, you need to have a deformation, right? But you have a big element here to resist. So this column is not gonna have a deformation until this wall deforms. If this wall is stiff enough not to deform with this load, this column is not gonna feel anything, okay? So this is the main resisting element. Maybe it takes 90% of the lateral force, and then the columns and the frames take 10%, okay? So that's what I was like telling you, that lateral load resisting system, we need a 3D model so that we can know how's the lateral load is resisted. Okay, so if you want to create this 3D model saying that this whole building have the same story, okay, I'm gonna save as this model. So save as, all right, I'm gonna say slab 5. And it's just very simple. You are just gonna replicate the same story that you have here. I'm gonna, for example, show this is the XZ. This is 1 story. I want to replicate this story to be 10 stories. So what I'm gonna do, I'm gonna select the whole building, like this building. All right. This building, I'm gonna select like this, and I'm gonna replicate it. But the thing is, if I did it that way, what is gonna happen? Like, I'm gonna tell SAP 2000, please take this whole thing and make another 9 stories out of it. What is gonna happen if I did it that way? Hinges, the boundary conditions are gonna be in every story, but I only have boundary conditions at the foundation, just the foundation. There's no hinges at the stories. Every story is free to move. Just the basic story is not. So the hinges are only here. So to do this, what I'm gonna do, I'm gonna come here and then go to view and then set 3D view. And I'm gonna make an XZ view. That's an XZ view that is 3D. What is the difference between XZ view, 2D and 3D? 2D, that means that you only see this side. But if it's a 3D, you see this side and everything behind. Okay? So if I select elements from this view, let me escape the selection that I have here. If I select something like this, look, that selects actually everything behind this. But if you have XZ 2D, it's only select the side that you are seeing, not everything behind. And I didn't select the joints. I selected all the elements in the model. Once I select all of them, I go to edit. You'll find something's called replicate. And let's see what we have here. Replicate, I want to replicate this story in the Z direction every 3 meters. And the number of replications are 9. And it asks you if you want to delete the original object. I don't want to delete the original object. I want to keep it. And then I'm going to hit apply. It's going to take a minute or something. What is the question again?
Why we don't go like boundary conditions with the floor? Because the floor is connected to the column directly, so each floor is free to move that way. The only floor that is not free to move, the one that is fixed to the ground. So it's the base floor. So hinges is only at the base floor, whereas the foundation at. Any other floor is is stable based on the column below this floor. We already have this column. So if I select the whole model with the hinges, that means that we somehow were able to make the floor is not moving. But the floor, if it hits with an earthquake, it's gonna move. Okay, so we only did put boundary conditions at the foundation level where we have the foundation. And if we have isolated footings, usually we put hinges. But if we have raft foundation or pile foundation, we will put fixation. So it depends on how the situation happening down here. Is this restraining everything, the bending moments and the forces and everything? So I can put fix in here. Okay, so it depends on the foundation timing, and it depends also on the soil. If it's like providing fixation to the column or just restraining the movement. Okay. All right. Hmm?
You design the columns because where I work, depending on who you ask, they tell you to design the columns in or design the column fixed.
You mean that's what I said. It depends on the foundation type.
No, like the columns between floors. Like sometimes some engineers tell me to pin it, and some engineers tell me to fix it.
Well, the thing is to design the final design of the column. Like we get the preliminary dimension based on the 2D model, based on the vertical reaction. Let's say that you get a column, for example, 50 by 50 centimeter. Okay. So once you have this column, we put the column dimension with the exact dimension because this is the stiffness that is going to absorb lateral moment. So we put them in the 3D model and then hit with seismic and wind and put all the load combinations that we have. Because if you look at the seismic load combination in the ESSE 716, you'll find that you have to put earthquake in X and Barth in Y, and earthquake in Y and Barth in X. So every time the moment is going to be exposed to lateral moment, MX and MY. One of them is big and one of them is small. Okay, so you have the two moments on the column. So we need to take this column to another software or maybe manually to design for bilateral depth. So it's not hinge or fix, it's just like how much moment is this column is absorbing. And usually we like if we have like a tall building like 60-story or something, we design the base floor, and this is the biggest column that we're gonna have. And then we like the way when you go up, this column cross section needs to go down. But the thing is, you have to design 60 times these columns because you have 60 story. Every story. But we don't do this. Maybe every 5 stories, get the moments, the forces, and then design, or every 10 story. Depends on how much. But sometimes, like designing columns is gonna save you a lot of money. So maybe every story that's gonna save you a lot of money. Okay.
Thank you.
All right. So right now we have the 10 stories. So let's see how this is gonna look like in the 3D. So I have here the 3D model. So once you have the 3D model, it's going to be a little bit heavy. So that's the 3D model of the entire building. Running this model right now doesn't make sense. Why? Because I already have all the information that I need. I have the bending moments on the slab. I have the reactions. I only need this model to put the seismic and wind loads. I'm not going to put seismic and wind loads right now. Okay. So once I have this model, the next step is to define wind load, seismic load, and then we are going to maybe next week, we're gonna see how these these loads, how we characterize them, how we define them. First, we are gonna take this from the structural dynamic behavior, and then we are gonna take it from the hazard analysis. How much hazard based on the zone, based on the soil, based on many things. So it has a structural aspect, which is the response, and it has the hazard aspect. So to do seismic analysis, you have to have two things. You have to have a course that's called the structural dynamics, and this is mainly study the response of the structure, not the hazard itself. And if you want to go in the hazard itself, you have to study the seismic loads analysis. So you need to understand how this hazard look like, how to start, how we describe them, how the codes deal with them, how the codes define them. Okay. In 2 lectures, maybe 1 or 2, I'm gonna give you a little bit of hint about how to do this, but not the whole thing. I'm trying to condense everything in 1 week so that we have like a little bit of introduction about the design for seismic, but to have the full perspective of the design process and the analysis process,
at least two courses. Structural dynamic course goes in depth in the structural response to lateral loads, and another course about seismic, which goes in depth in how the seismic loads are defined by the codes. All right, so that's actually the last thing that I'm going to talk about SAP 2000. We're not going to need it anymore, but this introduction was very important because if you know SAP 2000 and how to build models in SAP 2000, it's going to be easy to build models on ETAPS. And this is the software that we're going to use for the design project for this course, okay? All right, so let's see how to do this in ETAPS, how it's much faster, much easier. But let me ask you before I do this, what is the most difficult or tedious thing in SAP 2000? Like, what is the thing that takes lots of your mind or lots of overthinking when you do this model? Like, from what you see, what is the most thing that takes a lot of time? Meshing. Because you need to think every time, like, this wall is connected to the beams. Did I miss something? Did the walls, I divided them correctly? Is everything is meshing like right away? So you need to think about all this stuff. Other than that, just define material, define sections, draw, nothing. So meshing is the most tedious process when it comes here. And actually, this is a very simple model. In real life, there's no building that is that rectangle. Usually, if you have a multi-story building, the architecture has a crazy idea about lots of curvature and lots of things happen, and different slab thickness, and the corridor is like 40 centimeter, and the slab here is 30 centimeters, so you have to divide this slab into many divisions. But this is just a very simple model. And when it comes to this, you have to do all the meshing on AutoCAD. Because here it's gonna be difficult to do the meshing, like to connect the slab together. So it's gonna be really, really difficult. But let me show you how in ETAPS is much easier. So ETAPS, same way that you installed SAP 2000, you can start ETAPS, but I would recommend the same thing, like only install when the time, because I'm not sure when is the department is gonna get the licenses for ETAPS, but start and install when you need it. Okay, so let's say that you are gonna need ETAPS like in a 1 or 2 weeks from now, so don't get it from now. Just wait the 1 or 2 weeks just in case. All right, so when you open ETAPS, it's gonna be almost the same tabs over there: file, edit, view, define, everything. So let's see how it's different. So to make a model here, I will go to File, New Model. By the way, ETAPS is one of the most powerful software in analysis and design for buildings. Most of the buildings that you can imagine, the entire, like all the tall buildings, is done in ETAPS. Even Burj Khalifa, all the tall buildings is done on ETAPS. There's other softwares that are very, very powerful, but this one is the most powerful tool. All the firms are most of them, they are using this software. When it comes to 60, 100-story building, they use this software. And you're gonna know in a few minutes why is that. All right, so here before we start, it asks you very, very important question. What units that you're gonna use, because this is very important. Some in SAP, they don't do this. And I believe here is much better, because if you mess up with your unit, everything is gonna be messed up. So what I do, you can use save user like default settings, but what I'm gonna do, I'm gonna come here and I'm gonna use my built-in settings. So I'm gonna change the units from US metric to US to a metric. And if you are going to do design, and actually most of the firms, they do design with ETAPS, you can choose what standard you are going to use for design. US, you use AISC for steel design, and for concrete, you use ACR. Okay. All right, so I'm not going to do design, so I don't care about design much. I'm going to keep them, and then I'm going to hit OK. And once you hit OK, it's going to open something similar to the one in SAP 2000. Like, it's going to give you some templates to start with. And since ETAPS is only for buildings, not like SAP 2000 in general, like SAP 2000, you can do trusses, you can do stadiums, you can do stairs, tanks. So find lots of templates for this. ETAPS doesn't do tanks. It can, but it's going to be very, very difficult. Okay. It's only for buildings. So here it asks you, do you want to bake one of my slabs. I have steel, flat slab, waffle slab, two-way ripped slab, lots of floor system. But what I'm gonna do grid only the same way that I did it for SAP 2000, because I'm gonna do the same model that we have done. All right, so let's see how we can do it. It asks you for the grids in X direction and Y direction, but doesn't ask in Z direction. I'm gonna tell you why there's no Z direction here. So let's say we had, I believe, 9 grids in the X and 10 grids in Y. And the spacing, actually, they were different. So maybe I'm gonna put 5 for now. That's for X and Y. For Z, ETABS doesn't deal with Z directions. Always say the story. Is it story 1, 2, or 3? So you will have on the other side story data. So it asks you about the number of stories and how and the story height. So I'm gonna come here and then I will say the number of stories is 1 and the story height is 3. And it asks you another question: what is the bottom story height? Why? Because most of the tall buildings, the bottom stories are much taller than the regular story because it's the podium of the building. Maybe you have, I don't know, like a reception or something. This reception is 10-meter height, like it's a big hall or something. So, but right now I don't have a different bottom story height. So I'm gonna keep it 3, and then I'm gonna say, okay. All right, so here's a general grid system. I want to modify the grid system. You can right click, add or modify grids. And the same way, but here it divides the modification. If you want to modify the stories, it's different. If you want to modify the grid, it's different. So here, if you want to modify the story data, like if you want to modify the height, modify the number, you can modify them here. If you want to modify the XY stories, that's here. You can go modify the grid system. So right now, we knew that there's a little bit of difference. They separate Z from the floor system. Okay, so if you guys remember, do you guys remember the coordinates in the X directions? Right now we are talking long-term memory because that was last time. So that's what I'm good at. Okay, so we have 3 and then 7 and then we have 12 and then we have 14.5 because we have 1 in between, and then we have 17. And then we have 22, and then plus 4 is 26, and then 29. The Y direction is 0, 3, 7, 12, 13, and then we have a shear wall that is 3 meters, so 16, and another 1 meter, 17. 29. All right. So we are done. Like if I hit OK, you will find the same grid system that we have in SAP 2000. Do you guys remember? We have like our cores here, and then we have like a shear wall here and a shear wall here. Okay, right now I prepare the grid system and then I need to draw. But before drawing, we need to define the materials and define the cross sections, right? So the same thing that we have done in SAP 2000, I will go to define material properties, and then you will find your 4000 BSI here. And if you want to modify, you will come here, modify and show material. Then you will find out the material name, concrete, and then you will find the weight per unit volume if you want to change it, and the modulus of elasticity. By the way, even that we define the unit is metric, I can see different units here. If you want to change them, you can go here to units and make everything is consistent. Like all the units are ton and meter. You go here, consistent units, and then you want to make everything is in meter and all the force units are ton. Okay,
So when I go to define materials, and if you want to modify this, yeah, all these materials are already defined. But if you want to define new ones, you can. Okay, so right now everything is consistent. Like we'll find everything is ton meter. So right now this is 2.4 ton meter cube. You can adjust anything. If you have a high grade concrete, you can calculate the Young's modulus. It's 4,700 root the characteristic compressive strength of the concrete. You can't adjust anything here. But let's say we're going to use the default materials, and I'm going to hit OK, and everything is concrete. I don't have any steel. And after I define the materials, I can define the section. I can say frame section. I will find lots of frame sections already predefined here, but I want to add new property. And then I'm going to hit concrete rectangle. Okay, so I'm going to name this beam 25 by 70 centimeter. And I'm going to make sure that the material is right. And this is 0.7 and this is 0.25. All right. And I'm going to hit OK. This is for the beam. And I'm going to define a new property for the columns. I'm going to make sure it's concrete rectangle. And I'm going to name it column 50 by 50. 0.5 by 0.5, like same definition that we have done in SAP 2000. So right now I defined all the frame elements. Let's define the area sections. Okay, area sections here is not named area. They named differently, like you have slab or wall or the other system. So let's say slab section. And let me add a new property. And I'm going to say that this is a slab 25 centimeter. And I'm going to make sure it's a slab section because there's different type of slabs. I'm not going to go in depth on these. Maybe sometime we can talk about it. But right now I'm going to only select the slab. And I'm going to make this section as 0.25. And I'm going to hit OK. Right now I have a slab section. Next, I'm going to define another section. It's called wall section. I'm going to add new property. And I'm going to say that this is wall 30 centimeter. Okay, and make sure that the thickness is 0.3. Okay, I defined all the section in my models. Did I miss something? Beams, slab, walls, everything. Okay, so I'm ready, but before this, let's define load patterns. I go to define, you will find same thing, load pattern. Here you are gonna find out it's defined already dead and live. If you wanna define flooring separately, you can hit flooring and name it as a super dead and put 0, add new load pattern. All the load patterns, is there any much difference? Almost the same. Okay, define load combinations. I'll come here, load combinations, add new combination, and then combination number 1. Dead load, do you guys remember? 1.2. And I'm gonna add another one for the flooring. It's 1.2. How about live load? 1.6, and I'm gonna hit OK. I define load patterns, load combinations, everything is ready to draw. Okay, let's see how's the drawing look like here. Okay, if you wanna draw a column, look at this. I'm gonna use these ones. Can you see the one that has an I-beam section and has dot in the middle? That's a very way to draw columns here. Look what I'm gonna do. I'm gonna select this one. Once I click, in SAP 2000, it open a window here and let you select what section that you want to use. But here, it select the section down here. So I'm gonna select the column 50 by 50 that I already defined. Where is it? Yeah, here it is. And then I can come here at the drawing area and I can draw them one by one, like you can. Here, okay. Actually, it didn't pick the one that it's make I-beam. So like I want you to look, everything that you draw here is gonna show. Oh, what happened? Oh no. Happens sometimes. That's why we need to save it right away. Okay, let me. Oh yeah, that's a good thing that it allows us to save it. Sometimes it just, crash. The ETABS or SAP? Okay, let's say. All right. It didn't. Okay, I think if I want to show the 3D. Oh, now it's okay, closed. Right, let me open it. Actually, that was another one that I. Okay, so if I want to see the 3D, here you can click on this one. It's going to show you the extruded view. But actually, I don't want to see extruded view here. So I want to see it on the 3D view. Okay. All right. So if I make a zoom in here, you will find it's an I-beam section. That's not what I wanted. So I'm going to delete this section. All right, so let me do it again. I have here, draw column. It's called quick draw. So if it's called quick draw, and I'm gonna make sure this time that I have my column 50-50 selected. And then I'm gonna come here, I'm gonna draw the column. So you'll find here my 50-50 columns here, and then I have one here, one here. Next time, I'm gonna show you how we can use the AutoCAD drawings that we have to import it here and make all this in 1 second, like not drawing everything from scratch. So we're gonna use the AutoCAD drawings to automatically generate the columns, generate the beams, the slabs, and everything. So right now I did all the columns on the perimeter. Okay, so I believe I didn't mess any column. So if I zoomed, first I need to escape the drawing column section because if I clicked anywhere. Did I miss one? Oh yeah, there's one. I said that I did it. Which one? Oh, this one?
Yeah, the one at 10:08.
At 10A, okay. This one?
No. On axis 7 and 4, it's out of the X number 8 or
Oh, yeah. Yeah, I see it now. Okay. Should I put it on the, okay, let me, I don't know why it doesn't want to get me out of the. Oh, actually, there's one that is here. Okay, let me select these. It's a very slow now. Okay, let's delete these. Let's redraw them. All right. Let's close the drawing. Right now we are done with the columns. I just want to see how's the 3D look like. All right, so I have all the columns here. If I want to draw the shear walls, I'm gonna do the same thing. There is something. Okay, I need you to notice something. To draw a shear wall, look at these. These are the thing that would be draw the shear wall with. They are activated now. Look when I click on the 3D, what is gonna happen to them? They are deactivated. So to draw them, you have to be in the 2D. Okay, so I'm right now activating the 2D and I'm gonna click, there's something is called quick draw walls. So I'm gonna do it the same way that I did the columns. So here, the thing is, it asks you about, is this a beer or a spandrel? I'm not gonna talk about beer and spandrel right now, but the walls are called beer, okay? Spandrel, if you are gonna make a beam, not as a frame element, as a shell element. So we draw them as a wall, and we make it as a spandrel. And I'm gonna talk about beer and spandrel later when we talk about shear walls. But right now they are beer, and the section is wall 30 centimeter. And I have a wall here. Oh, actually, I'm not gonna do them. Maybe quick wall. All right, let me do it that way. Actually, my plan is like actually to draw them by this tool. Like you pick the first and the last point, but this one is much faster. So I'm gonna do this by click the grid that I want to make the wall at. And if you notice in the 3D, the wall is drawn, and actually there is boundary conditions, so you don't have to assign hinges. It's already assigned. And at the column as well. So, all right. So you can actually draw the shear walls, the core in the middle, either by the quick draw or by this one. So I can use this one, and I can go point by point. And then I'm gonna make a right click. And then I'm gonna start another one from here. So I draw all the shear walls. I'm gonna escape. And then I'm gonna draw the beams. So I'm gonna make beams around the slab. So I'm gonna click on this beam and I make sure to change the section to beam. Sorry, I hit escape by mistake. And then I'm gonna make sure that I select beam 25 by 70 centimeter. Okay, I have a beam all around the perimeter from here, here. By the way, it shows you in the 3D that the beam has a depth, but actually as an analysis, it's still a frame element. It's not a solid element. So all these elements are still frames, like all the columns and the beams, they are all frames. The only way to make a beam as a shell element, like it has a depth, is to make it as like a wall. Like, let me show you. Here, if I want to make the beam here, and actually that's what we do in the analysis. If we are drawing a coupling beam, we call it a coupling beam, when we draw it between shear walls, because it couples two shear walls together. So if we want to do it, we do it as a shell element. How? Let's see. I'm gonna draw a wall. And by the way, this is a beam, but I draw it as a wall. And I'm gonna tell you what is the difference that we're gonna make right now. So I'm gonna make it as a spandrel. That means, like, I'm telling ETAPS, actually, this is a beam, but has a walled section because it's a coupling beam, which is a special beam that connects two shear walls together. And it's gonna take the same section of the wall, and it has depth below the below the floor, for example, 0.7. That's above. I'm gonna make it blue. Okay, let me see. So I'm gonna draw a beam here. I'm gonna stop here so that there is a connection between them. Even if you didn't stop, the software is gonna create a joint here. Okay, let's see what happened. Right now, I draw a beam. Let's see in the 3D how it's look like. Can you see the beam? It's not a wall. It's not going from top to bottom. It only goes down 70. You can actually make it for all the beams in your cross section, but the analysis is going to be more complicated. We need the analysis to be accurate at the shear wall location. Okay? Because we're going to talk about the coupling beam later, maybe next week or something. All right. So I'm done with everything except the slab system. For the slab system, you will find row rectangle. And then I'm gonna come here and I'm gonna say slab 25 centimeter. And I'm gonna make a slab all the way until this point. Okay, I drew the slab system. What is missing? I need to make a void inside the slab at the elevator. So you can come here and then you can make opening. And then you can make an opening like this. Okay, I made two openings in the slab. Then once I do them, I can assign the load, can select this slab system. And then I will go to assign shell load and then uniform. And then I'm gonna put dead load is already the on weight. So I'm gonna put flooring. If you guys remember the flooring, we had 0.15. And then I'm gonna hit apply. Then I'm gonna select the slab again. And I'm gonna put live load. I'm gonna make it 0.2 the same way that we have done it in SAP 2000. And right now, I'm done with everything. What is missing? I did everything that I have done in SAP 2000 except meshing, right? Here in ETAPS, there's a very, very powerful tool called auto meshing. So basically, you tell ETAPS that I want a maximum mesh of 1 meter by 1 meter or 0.5 meter by 0.5 meter, and it's gonna be everything and connect everything together. Let's see where it is. Okay, I don't have to click on anything. Like I don't have to click on a slab or something. So I believe it was in define auto mesh. I believe it's analyze. Yeah. Oh, yeah, here it is. Automatic mesh settings for floors. You can come here and then you will say that I want to automatically mesh this floor, and you can either make it general. Like general means it can divide the mesh into any shape, like whatever it's going to be, rectangle, whatever. Or if you want to make it rectangle, so you put a maximum size of 0.5 by 0.5. Or for example, we can make it 1 so it can run faster. Or you can keep it general and then hit OK. And the same way you can do analyze and then automatic rectangular mesh for the walls. And then you can make it 1 or 0.5 and then hit OK. So right now we are ready to run the analysis. So here it says everything that CAPS is doing, it shows you here, like if it's done with the analysis, preparing the analysis. So right now it's doing the analysis 10%, 55%, running all the cases. And then once it's done, it's gonna show you the results right away. And actually CAPS is very good in visualization and showing the results. So right now, once you have the look is looked, that means the analysis is done. And then you can start showing results. Like I can show, for example, deformed shape, like here. And actually the mesh is a little bit bigger than the one that we saw in SAP 2000 because we made it 1 meter. If you want to make it less, you change it to 0.5. It's going to take much longer, but that's fine. All right, I want to get to the deformed shape. To do this, I need to get here, show deformed shape. And then you can change whatever you want. You can change actually to combination. I want to show the deformed shape due to combo 1. And I want to show contours in the Z direction. And then I'm going to hit OK. The same way that I did in SAP 2000. So I can see contours. Where are the maximum deflection, as I can see here. If you want to show bending moments in the slab, you can, or the beams, you can come here. And then you, for example, you can select combination 1, moment M33, and then hit apply. And you can see the bending moments on the frames. So let's, okay. To see the bending moments, you have to not to be in the extruded view. It has to be something like frames like this. And you can see actually on the 3D and the 2D. Like I can make this 2D like XY, like plan. And I'm gonna hit, this is story 1, okay. And then I can see the bending moment at every cross section. Looks very good. If you want to see the bending moment, you can select here and then click here and see the bending moment on the slab. And then I'm going to hit, for example, M11, and I'm going to say it's due to combination 1. And then you will see the bending moment. Look what happened here. You will see the bending moments, but you remember when we made this, the slab has a general mesh. Look what happened here. It makes whatever faster the mesh is. If you change it to rectangles, you'll never see these shapes. This is not wrong. This is right. Okay, the way that it meshes is gonna give you the same results if you make it rectangle. But this is the fastest way to make the mesh for SAP 2000. So maybe you change it to rectangle and see what is gonna happen. And actually, when we make the mesh on AutoCAD, it comes out like this way.
right? So that's the 2D. Next time we're gonna create the 3D and do some other interesting stuff, okay? All right, so that's it for now and see you guys on Thursday.